I am Yu Wang from Group C. The schematic is the positive terminal connected to the LED, connected to a resistor, and then connected to the negative terminal of the battery pack. So schematic. And then we have the breadboard, the LED, the long leg and the short leg. Long leg is the positive end and the short leg is the negative. That is the LED. That's the resistor. We have the negative end of the terminal going into one of these sockets. Then the positive end into this socket. And then turning on the battery pack, the LED should light up. That's the circuit built. And so this node right here on the schematic is the connection between, let me just turn off the light so you can see it better. So the node here on the schematic, the connection between the positive and the LED is right here. Then from the connection from this node right here, but for the connection between the LED and the resistor is right here, in between this leg of the LED and the leg of the resistor. And this node right here is the connection between this leg of the resistor and the negative terminal of the battery pack. Now it's to demonstrate how the standard sockets are connected. If I turn on the battery pack and pull out the negative terminal, I can put it into any one of these sockets and the LED will light up. I can do the same with the positive terminal. As long as it's within this row, the LED will light up. But once I put it across this divide, there is no connection between this side of the breadboard and the other side of the breadboard, so the LED will not light up. Now, I will demonstrate how the rail sockets are connected. If I pull this positive wire and put it on the positive rail, the rail runs along the positive section. There's two sides. And if I grab a wire, I just never put this. Now, if I connect the white wire to one of the rail sockets on the positive rail on any one of the positive rail sockets, as they are all electrically connected and connected to the same row as the LED will light up. And I can just use the other positive rail as well. Since the circuit is not connected, I will use a second wire to go from this end of the positive rail socket to the other end, and the LED will light up. This can also be done with the negative, with using the negative rail sockets. And with a wire between any one of the negative rail sockets connected to the row with the resistor on it, and the LED will light up. And I can place any of the wires in any of the sockets on the positive rail socket on this rail, and the LED will light up. Now, the current goes from, oh, let me show. That's disconnected. Well, let's reconnect that. Oh, this is a bit dodgy. Now, so the current is flowing from the red wire from the battery pack through the red rail in the red rail socket to this white wire, along this white wire to the opposite positive rail socket, down to this wire connected to the LED. The long leg of the LED goes through the LED, the current goes through the LED, through the resistor, through to this white wire that is connected to the negative terminal, and that goes back towards the battery pack. And I need to fix that because it's not working as intended. Now that's the current. And then for the second LED, I'm just gonna make a bit of room. So I'll be disconnecting the circuit. And I will grab my second LED. Plug it in here with the resistor. And then reconnect the circuit, and both LEDs will turn on. And just to make a bit of room, I don't have much room to work with. Now, to bypass the first LED, I will connect my green wire. I've run out of white wire. I will connect my green wire between the first one and between the resistor to turn off to bypass the first LED and have the second LED light up. And everything on my checklist has been shown and updated during the video. Thank you.